when you call ECALL assembly instruction in the user mode, an exception will be generated, and this operation will be broken into the first step. So let's dive into more about this operation. In the first step in the user mode, ECALL assembly instruction is performed. Before running ECALL assembly instruction, the system call number is specified using A7 register. The A7 registers will be accessed in the trap handler to find out the corresponding system call handler. This is the first step. The user application runs ECALL assembly instruction. Using ECALL assembly instruction, system call can be implemented. System call can be invoked from the user space to the kernel space. So this is another important operation. That is, system call is the terminology of the operating system that is the interface between user space and kernel space. And in order to implement the system call, we need the sort of the trap or exception to get into the kernel space. This is done using ECALL assembly instruction in the RISC-V architecture. Once you run ECALL assembly instruction, the RISC-V core will start to generate exception. This is the second step. In the second step, this operation is performed at microarchitecture level. What it means is that we cannot see any of assembly instruction because it is performed by hardware level. And the next thing is RISC-V heart, RISC-V core will update several important control registers such as supervisor cause register and supervisor exception and program counter register, and also it will update the SPP bit field inside supervisor status register. And the last thing to do is to move to the trap vector base address that will be performed in the third step. As the first step, the program counter will move to the trap handler. What the trap handler does is to read the value of the S cause register, supervisor cause register. By reading the value of the supervisor cause register, trap handler will identify why exception happened. And then it will read the system call number using A7 register. So using the A7 register, the trap handler will find out the corresponding system call handler. Later, the corresponding system call handler will be called based on system call number. For example, let's suppose that write system call was invoked in the user space. In this case, the write system call handler will be called in the trap handler by reading system call number. Let's suppose that read system call was invoked in the user space. That read system call number is already specified using A7 register. In the trap handler, after it reads the value of the A7 register, the corresponding read system call handler will be called. This is how the system call can be invoked in the trap handler. Now we understand how ECALL assembly instruction works when generating the exception in RISC-V architecture. The later lecture we will perform interesting debugging practice using trace-redo debugging program. That debugging practice, we're going to run the ECALL assembly instruction in the user mode.